Voila. Is Megan the only one missing? Yeah. Okay. She's the only one watching this, so it doesn't matter that I said her name, right? Do I have to like start recording again? Okay, that was fine. Okay. The type of function. So the type of function is either linear, quadratic, cubic, quartic, quintic, and I don't care after that because that's where we stop. Named Bolero for all I care. Don't care. I don't know why Bolero came up. It's like a jacket. Well, you're welcome. You're in my brain for a little few seconds there. That's what happens. Like random Bolero. Where did that? I don't even know. Okay. Good times. So A is A what? Ooh, I have to call. Oh, this is good. Johannes. What is the type of function? They're gonna be like, it's not quintic. A, my friend. Johannes, I can't call you that name. It seems you went downhill with the name. Let's say. Q. Yeah. And degree what? 3. Spartacus. What type of function is B?
It is quartic.
Yeah, I knew you were doing that. Quartic. Because I knew you knew that. And degree?
4.
Johannes, we'll pull you back because we know you know that you were answering this one. What is this one? Quintic. And its degree? 5. Ari? See, I already have one for you. What is this one?
4.
And degree?
4.
Okay. The end behavior. Oh, mother. Look. Get into the chair. Fine. It's good. Okay. End behavior. So, I forgot to say it's odd or even, but I think you can figure out that 4 is even and 3 and 5 are odd. Do you agree? Okay. Genius class here. I know you can do that. Okay. So, we need the end behavior. So, we look to the leading coefficient of A. It's going to end up on the right. And it's going to end down on left, right? Because it's odd. So down on left, up on right. Could we do that on the diploma and just assume they know what we mean? Please don't. I know the words. Okay. B, it's negative. So it's down on right, and it's 4, so it's down on the left. Remember, we do right first, then left, based on the degree. It's negative. So it's down on right. It's an odd degree, so that they're going to be what? Talia? Up on left, because they're always opposites, right? They disco. The odd ones disco, because they're odd. Because who else discos? Okay. Play. Positive leading coefficient, so what is it on the right? Up on right. And then it's an even, so it's, yeah. Number of possible x-intercepts equals the what? There you go.
Great.
Yes. So, if this is degree 3, we have 3 possible x-intercepts. If this is degree 5, we have 5 possible. But that's the maximum, right? Does that mean we always have that many? Nah, it doesn't. This isn't messy at all. It's actually making my insides hurt writing it this messy, but that's okay. I'll work through it. Magic. Okay. Whether the graph is a maximum or minimum. What graphs only have maxes and mins? Hell.
I don't know what the one, but the degree 2 and degree 4.
Yeah, so the even degrees. The degree 2 and the degree 4 have maxes and mins. So this one's degree 3, so it doesn't. No max min. Now, technically it has maxes and mins along the way, but it doesn't have absolute ones. Okay? So, no absolute, I should say max or min. Okay? But this one could have maxes and mins, couldn't it? Degree 3s do that S shape, correct? It could have a max and a min, but no absolute max and min. Okay? So this one, B, has, it's concave down, so it has a max, an absolute max. And it could have some mins too. right? But we're just going to discuss absolutes, like the highest and the lowest can be. The degree 3, 5, and 1 have no absolutes because your arrows are in opposite directions, disco, right? But it can have mins and maxes along the way, and you would have to tell those. So the only thing I'm looking for right now is absolute max and mins, but if it just asks for max and mins, I'm saying absolute right now, but if it asks for max and mins on a test, you have to save those ones in between using your calculator, okay? Degree 5 has no absolute max min. And when I have no absolute max min, what does that affect? Or having an absolute max min, what does that affect? Yeah.
Range.
Your range, yeah. So if there is an absolute max min, our range is going to be less than or equal to or greater than or equal to. If there isn't an absolute max min, Stephen, what's it going to be? If there isn't an absolute max min.
Your range. Or
Yeah.
Infinite.
Infinite. So negative infinity to positive infinity. Yep, or YER. You got it. Then this one would have an absolute, because the arrows are both up, it would have an absolute minimum. So this is all information we can pull from here without having to type these in our calculator to match graphs, right? Like we shouldn't have had to type these in to match graphs. All this information should be able to make us match graphs. And then the y-intercept is our what on our equation if the equation does not have brackets? Weston, which is our y-intercept if it does not have brackets? Which number?
Would it be your constant?
Yes, our constant is our y-intercept. Because when we plug zeros in for x's, these all go away. We're just left with the 2. Why do we plug 0 in for x? Because when you're looking for y-intercepts, x equals 0. So our constants are our y-intercept. So our y-intercept is at 0, 2. This one's at 0, 1. This one's at 0, negative 6. This one's at 0, 16. So we know A is a degree 3, so that's going to make kind of an S. So it'll either make an S that looks like this, where there's actually a max and a min, or an S with a point of inflection like that. Okay? I know they're up on the right because it's a positive leading coefficient. I know it's down on the left. So I'm looking for an S up on the right, down on the left. Well, that looks like D. Let's check some more things. Y-intercept of 2. Y-intercept of 2. Boom. Right here. This baby's D. So I'm going to put a little a beside D. Or you could put a capital D beside A. It doesn't matter, right? You're just matching them. Then I'm going to go to my 5. My 5 has the extra bumps in it, so it's A for sure, because it's the only one. But let's check it. It is a negative leading coefficient, so it's down on the right. It's up on the left because it discos, because it's odd. It has a positive 1 as a y-intercept. Boom. Fantastic. It's no absolute max or mins. It's quintic. This one is C. Then B and D are actually easy to tell apart because B has arrows pointing down, C and D has arrows pointing up, right? Because of the leading coefficient and the degree. But we can still check our y-intercepts. So this one's arrows pointing down, so it's going to be B because it has a negative leading coefficient and it's degree 4, they're in the same direction down. And it has a negative 6 as a y-intercept. So good check. And then D has a positive leading coefficient. So it needs to both end up on the right, and a y-intercept of 16. So this would be little d. Right? So we don't have to type them in our calculators. We know so much information from the equation. When the equation is not in brackets. When the equation is in brackets, so when we just have like y equals x plus 3, 2x minus 1, x plus 4, when it's like this, we still know a ton of information. We actually know more than the previous one. Why? We know the x-intercepts because we can solve these out, right? So we have x-intercepts, which here we only know the possible number, but from there we can't directly get our x-intercepts. We have to factor and solve. So here we get the x-intercepts, and what did I tell you to do to get the leading coefficient? Make sure it's at x plus, x plus, x plus, or x minus, x minus, x minus, right? To get the leading coefficient, I multiply, multiply, multiply. So my leading coefficient of this one would be 2x cubed, which means it's positive, which means it ends up on the right, down on the left, because it's an odd degree. So I know even more information when it's in brackets. I used to do a little bit of information, a little bit of math to get there. And I can get the constants, because I could technically plug 0 in and just solve them. Or I can remember to multiply my back numbers, and it's negative 12, which gives me 0 and negative 12 as my y-intercept, right? So actually, in the brackets, people think I have less information. I actually have quicker way to get more information. It takes me a little bit more energy to get it, but right away I can get my x-intercepts. They're at -3, a half, and -4. My y-intercept's at 0 and -12 when I multiply the reds. And my leading coefficient is at 2x cubed. I know it's a degree 3. I know it has a positive leading coefficient. So it's up on the right, down on the left, right? So very quickly I can pull information from ones like this. People forget that. They think that they need to expand the whole thing out. You don't need to. But we instantly get our x-intercepts, which is even better than the previous equation. But it needs to be x, x, x as your leadings, right? All the variables. If they don't start, you just need to know you need to multiply all the x's to get the leading coefficient, multiply all the numbers to get the constant. All right. This question. A skateboard manufacturer. Now this is the catch. So our domain is always XER for all polynomials. We agree? It's XER, XER, XER. Unless it's a word problem. Because sometimes XER doesn't make sense in a word problem. For example, this one. So it says, a skateboard manufacturer determines that a profit, P in dollars, can be modeled by this function. So P is the profit is in the Y spot, so Y equals profit, right? We can correlate that. So we know that our Y variable, or our P of X variable, is our profit. So if ever they give me the profit, I would plug it in for my P of X, okay? The thing about word problems is they always tell you what the variables stand for. So you'll always know, you just need to go looking for it. Then it says, where P of X equals 1000x plus 1.25x to the 4 minus 3200. So it's out of order, but this is a degree 4. This is a coordinate, right? Even though it's out of order because we take the largest degree. So the leading coefficient of this is actually 1.125, right? It's not 1000. Some people fall to that. Don't fall to that. Where X represents the number in hundreds of skateboards sold. So this is hundreds. All these X's, hundreds of skateboards sold. Well, I instantly know this. I instantly know that X has to be greater than or equal to 0. Why do I have to limit it to that? Why is my domain restricted? You can't have a negative number of skateboards. You can sell none. You can that is as sucky as you can get. You can't like make some vanish. Like, okay? So as sucky as you can get is selling none, so we can put it equal to or more, right? Now profit. Can we profit less than 0? That's a trick question. You can actually profit less than 0 if you have a startup cost, right? If you have initial costs to make those skateboards, before you sell them, you could sell none and lose money, which actually is the reality of making anything. Making everything makes cost stuff to make stuff, right? So if you sell nothing, you're going to be in the hole, because in order to manufacture those skateboards to get them running, it costs money, right? And you were taught this in grade 11 as well, but this constant here, and in grade 10, because in linears it gave it to you, this constant here is your y-intercept, correct? So that's at 0 and negative 3200. Well, what the heck does this represent? This represents 0 and x. X stands for what? Skateboard. Oh, that's not really good. Right? And the y represents what? My profit. Do you agree? And I said we can start at no skateboards. So at no skateboard sellings, how much profit do I have here? Negative $3,200, right? So if I sell no skateboards, I am in the hole. So what's the lowest I can go? What's the lowest amount of money I can lose, I guess, catch it? That 3,200, right? If I sell nothing, it correlates directly to 3,200, or I can make more. So if I wanted to do my range, I'm not going to go y. What is my variable? P of x. So that's what I have to use for my range. So don't fall when it's word problems. It's going to be P of x such that P of x is greater than or equal to negative 3,200. P of XER. You have to use the variable that they have. If you go y is to be greater than or equal to negative 3200, the teacher's like, okay, where's y? I don't even know what y is. Why are you talking about y? Right? So you have to watch that we use the proper variable. So just from the equation, I can correlate, and the actual word problem, I can correlate, okay, I can't have less than 0 skateboards. That makes no sense. And I know that at 0 skateboards, which I've limited to, right, I have actually negative $3,200, right? So I can only go up from there. Okay. So what is the degree of the function? Its degree, Chloe? 4. So what are the leading coefficient and the constant of this function? What does the constant represent? Well, we kind of went over this. What is the leading coefficient? Okay, I wanted to say your name and I made it up, but I can't remember what it is. What was my name? Johannes and? Spartacus. Dang it. Spartacus. I just really wanted to say it, I couldn't remember it. What is the leading coefficient?
1.25.
Can we do LC on a test? No. Can you do it for yourself? Sure, because you know what it means, but you can't do it on test. LC equals 1.25. And the constant is what, Kevin?
Negative 3,200.
And what does it represent?
Expenses.
The profit at how many skateboards? What is it? It's the profit at how many skateboards?
0.
Yes. Describe the end behavior of this function. Well, it's going to start somewhere at like negative 3,200. I don't know why I drew it like that. And it's a degree 4, so it's going to do something and end up. Is it going to do like all these bubbles down here? No. Who knows what it's going to do? You'd have to type in your calculator to see what it's going to do. It's going to do something, but we know it's going to go up, and we know it's going to start at negative 3,200. That's very much what we know from here, right? We can't say exactly what bumps are going to happen along the way just from an equation. That's like insane. If you can, wow, good on you. I cannot. Okay? We do know that it ends up on right. On left, it starts at 3,200. Negative 3,200. Now, up on right, does that make sense? As I go along, it's just going to keep going up, 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 up. My y represents my profit. So is it going to continue to go up as my x's increase? Yeah, the more skateboards I sell, the more the profit, right? So there's an infinite number of amount of profit I could have here. It's probably not going to be an infinite number of money, but in this graph correlating with this equation there is. Now, what are the restrictions on the domain of this function? Well, we already did it. X such that x is greater than or equal to 0. Or I could say domain. And I would label this as domain as well. If it's greater than or equal to, you start at the number and go to infinity. And I put a square bracket because, well, that makes sense. What do the x-intercepts represent? Did anyone find them? Stephen?
It represents that your costs are breaking even, I guess.
Right. So it's when X number of skateboards will make it so you make 0 money, right? Because we know it's skateboards and money, correct? Well, we know it would be number of skateboards. Oh, that's a really round one. It's more like a hoverboard. Magic coming out again. And 0 profit, right? Because for an x-intercept, my y, my profit would have to be 0. So what is the graph, with x-intercepts of the graph represent? The number of skateboards. Can I write the number sign on my diploma? Would that be okay? Please don't write any short form, anything. Nothing, except for LS, RS. LS means left side, RS means right side. In mathematics, it means that you can use it. There's my short form. You're welcome. LS, RS. Anything else? Be like, should I write it short? Don't. Don't even question it. Don't spend that time. Just write it out. So we can, in our notes, write a skateboard or a hovery kind of looking board, and we can write number of in our notes. But on the unit test and on the diploma, we will not do that. Okay? So it's the number of skateboards that need to be sold to break even. It's my break-even point, right? What is the profit? Now, this is the catch. What is the profit for the sale of 1,200 skateboards? Now, did they give me X or did they give me P of X? Yeah, X. Now, if I put 1,200 in for X, Weston, what's going to happen?
You get more money than exists in the world.
Right. Because this word problem, I made a point of doing this. X is hundreds of skateboards sold. So X represents hundreds of skateboards sold. So if it's hundreds of skateboards sold, this is 1,200 skateboards. So that's actually 12. 12 is what I need to put in because it's in hundreds of skateboards. So every 100, I'm going to write as a 1. So if there was 100 skateboards, I'd put a 1. If there's 200 skateboards, I'd put a 2. If there's 1,200 skateboards, I'd put a 12. If you put a 1,200 in, add 2 zeros to this, you're actually finding the profit for 120,000 skateboards, not 1,200. Okay, so you have to watch what the units are in. So we don't need to even use our calculator. Technically, we can. We're going to go over that as well. But I'm going to show you the algebra. So we can go P of 12 equals 1,000 times 12 plus 1.25, 12 squared, 4, not squared. This is the 4, right? Minus 3,200. Did anyone get the actual answer? P12? Weston?
I think it's 34,720.
700 and, pardon?
20.
So would we just leave it like this on the diploma? When it's a word problem, and we have a sentence, we need to write it. Did anyone else get the same answer? Yeah? So, we're going to say, what is the profit scale of 1,200 skateboards? Literally, you should write a sentence because it's not hard. Like, if there is any English in the world that is the easiest thing to write, it's just rewriting a question. Like, I can do this. And I am not strong in English. English is not my friend. Okay? Like, I speak it. But if I have to write it, I kind of cry. So, like, when my daughter had to do a 10-minute quick write for grade 4 while she was gone last week, and she had to do a 10-minute, I was like, that is the meanest thing on the planet. 10-minute quick write. It takes me 10 minutes to, like, get through my emotions to realize I need to write. Maybe if I would have quick righted, would have done a quick write. Quick righted, I would think. If I would have done a quick write since little, I probably wouldn't have this experience of, like, freaking out when someone's like, okay, so we're going to write something. I'm like, dude, no. And then it's like a good 45 minutes. I'm like, you can do it. Just pick up the pencil. Start typing. You'll be okay. I promise you. Maybe if I did some quick writes, I wouldn't have that fear because you have to pick up and you just have to do it, right? So I think it's good that kids have to quick write from little on. If I didn't have to, I have no quick writing skills. Like, it's nothing. Like, it's like, you want me to do something quick? Ready? No, thank you. Oh, you're welcome, Megan. You get to hear it. Forgot I was still recording. It's good. It's fine. I'm just sharing my emotions. Okay? It's good. So, back to this. Because it said spring. So it says, what is the profit from the sale of 1,200 skateboards? The profit, it's like literally rewriting this equation. The profit from the sale of 1,200 skateboards is 34,720. Okay? Literally the easiest thing. I have no heart palpitations when I have to rewrite a sentence from a question. Like, I can do that. So I know you can. Okay? We're going to do that when we see written response. Like when it says, determine the coefficient, you're going to write the coefficient is and write what the coefficient is. Okay? We're going to do that. Because literally people lose marks because you don't actually tell which is the coefficient, which is what they're asking you to do. You just find stuff. And you're like, they must know which one is the coefficient. I believe in them. Don't believe in them. Okay. Now, this is fun, because none of yours is going to look the same, because this is open-ended. And open-ended questions end up on the diploma. Open-ended up question, open-ended up. See, it's happening. Open-ended questions end up on my unit tests, too. Because why? You guys are really good if I'm like, the y-intercept is this, coefficient is this, constant is this, the x-intercept is this. You're like, boom, boom, boom. I will draw the graph. This is fantastic. Give me an equation. I can pop that baby out, no problem. I can tell you anything about it. Then I'm like, give me a polynomial, degree 3. Y-intercept 16. You're like, there is not enough information. This is not good. I do not like this. And then I'm like, now determine an equation of your graph. And you're like, oh gosh, what is happening? Okay? That will happen. That is a real situation. Okay? So we're going to go over that too. Just not the equation yet. So, polynomial function degree 3. I know it's discoing. Right? That's a disco something. Okay? I know it can be an S like this, or it can have a max and a min. I'm not saying it's that way, that direction. I'm just saying what the shape could be. Or it could have a point of inflection where it just curves through. There's not really a max nor a min. Okay? Those are my degree 3 options that are for me. Now, if I need more than one x-intercept, if I need like a 2-1 or something, then I'm going to have to put some bubbles. Okay? Some max and mins. All right, so we know it's going to be one of those shapes. Oh, it has a positive leading coefficient, so we know it's going to be more shapey like this, at least. It could still be like this, but it's going to have to do something like that then, right? Because in order for it to have a positive leading coefficient, it needs to end up on the right, it needs to disco, so it needs to end down on the left. So we're narrowing down where our graph can have options for. It has to have 2 x-intercepts. Okay. If I do this graph, this one here, it has to have 1 or 3 x-intercepts. This is not an option. And I'll show you why. Do not draw this. It is wrong. So it can have 1 x-intercept because it could do something like this, right? 1 through it. Boom. Or it can have 3 because the point of inflection can actually go through the x-axis. That could be where my x-intercept is. That little curve. And when I have an S-curve, remember I have at least 3 x-intercepts there. I could have 5, I could have 7, I could have 9, I could have whatever. But this is a degree 3, so at maximum that could be 3. Because I can't have more x-intercepts in my degree. So the point of inflection one is not an option. We can't even choose it. Because I can either have 1, where I draw the inflection point up higher, or 3, where I draw the inflection on. So this is not an option for here. So I have to do something bumpy. Okay? Now, don't draw this again, because this is going to be wrong. If I do this, and then make all the bumps go through, how many do I have? I have 3. Okay? So that's not going to help. Can't do that. I could do this. Because this is technically 1 x-intercept, 2 x-intercepts, correct? We just happen to have how many here? Remember when this is tangent, we have how many there? 2 or 4 or 6 or 8 or 10 or 12 or 14 or 16. In this case, I have 1 here. This has to be 1 x-intercept, but there happens to be 2 of them there because 2 plus 1 is 3. So this just means 2 different x-intercepts, not 2 total. So this is a different x-intercept. This is a different x-intercept. They're 2 distinctly different x-intercepts. There just happens to be 2 of the exact same one here. So it causes it to come up and bounce back down. So we could do that. Or we could go through and bounce on the top. I want to make it so I can actually show you with the equation. Drawing this terribly. So let's say it's like that. So I would have x equals -4. And I could say multiplicity 1. But you don't. And then this would be x equals 3, multiplicity 2. Now the reason why It has to be multiplicity 2. When it bounces, it could be 2, it could be 4, it could be 6, it could be 8, it could be 10, it could be 12. But when I add my multiplicities, they can't be more than the degree. So even though this could be 2, 4, 6, 8, 10, it has to be 2 because 2 plus 1 is 3. It can't be 4, it would have to be at least a degree 5. Does that make sense? Now, people forget about this. This bouncing, what happens is I have an x-intercept here, I hit it, and then I have another x-intercept so it causes it to bounce. That's how you get the bounce because there's 2. If it's 4, it like bounces, 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 bounces back up, right? This, everyone forgets what it's called. It's called a point of tangency. And I'm sure you were taught it last year when your vertex landed on the x-axis. It's a point of tangency. So whenever you get that bounce, you have one x-intercept, but it's just happening more than once. It's happening even amounts. So 2 or 4 or 6 or 8 or 10. How do you know which one it is? Well, if they give you a degree, that's going to limit you, right? Or sometimes on the diploma, what they'll write is the minimal possible degree of this graph. The minimum possible degree. So the minimum possible degree of this would be 1, 2, 3. And it has to be odd because I can see that the shape is this. So they can give you a graph mass for the minimum possible degree as well. Okay? Next one. A polynomial function degree 4, so I know it's going to make a W or an M of some sort. It has a negative leading coefficient, so it's going to make an M because I need to be down on the right, also down on the left because it's an even degree. And it has 4 x-intercepts. This is the nicest one ever. You're literally just going to make that baby curve through. You could make your maxes the same. You could make it be like a really nice M. Or you can go all wild and be like, would that be okay? Did I follow the rules? How many did I give you for x-intercepts? 2. So is it possible to make less than 4? Yeah. Make your bumps below or above, right? Could I make 3? Yeah. I could just make this bump come down and touch it, make a tangent. Tangents always pop off an x-intercept. So if you ever have you need 1 less, you can tangent to make 1 less. Okay? So I actually have to make sure that this whole thing bounces through. Okay? Now please don't do something like this. You laugh. I see this all the time on the written response. Or it's like a parabola is like this. I'm like, what in the heck is that? That is scary. That's all that is. Yeah. All you bad drawers. Okay? I'm terrible at art. I can even draw them symmetrically. Okay? So remember that your degree 2s and degree 4s graphs are symmetrical. So they will bounce an even amount. Like the quadratic when you drew it in grade 11, hopefully, which you probably didn't. You probably had the crazy looking ones. It was symmetrical, right? Nice little U. Same with the W's and the M's. They're symmetrical. So if you have one really squished, you can have it squished like this, but the distance from here to here will be a nice distance. Your x-intercepts can be closer depending on if your x-intercepts are actually close, right? So these ones are very symmetrical. These ones are just a nice looking. Don't curve back is what I mean. They don't do any weird curvy backy things. That's not even a function anymore. Okay? It's bad. All right. This one, polynomial with degree 4, positive leading coefficient, so we're making a W of some sort. And 2 x-intercepts. Now, what's going to happen with a little bump in order to get 2 x-intercepts? It's going to have to be below the x-axis, right? The moment it goes through, it's going to cause me to have problems. I could do, no, that's the easiest way. Right? Now, Right now we're not having to make equations of these, but when we have to make equations of stuff, what do we want to do? We want to make our x-intercepts actually go through nice x-intercepts, right? We want to make our y-intercept go through a nice y-intercept. So what do I see? I see this. Oh, I got to make that go through a nice one. Okay, I got to make that go through a nice one. Okay, I need a nice y-intercept. And then you can't just like, there's no, it's just, okay. So sometimes what happens is your graph, you want it to be a nice y-intercept, totally fine. You come up with an equation that matches your convoluted graph, okay? You get your equation, you now type it into your calculator and you redraw your graph to go with your actual equation because your graph's convoluted and looks weird, okay? So once you actually get your equation of the graph you've decided to draw, go back and probably redraw your graph. It's probably a little wonky, like your max and mins probably aren't in the right spot. You may have it draw like a straight across y-intercept when it's actually going like something like this, okay? It's totally fine. You can manufacture your graph first. You'll get your equation. You'll put it into your calculator. You'll redraw your graph to actually match your equation. Okay? Totally fine. So you can have a wonky graph at first. Just go back and make it not wonky. All right. So these ones we haven't done. So for each graph of the polynomial function, determine whether the function has an odd or even degree. So now instead of giving it, we could just look at the graph. Determine whether the leading coefficient is positive or negative, state the domain and range, state the number of x-intercepts, y-intercepts. I am going to, for now, ignore that there's actually an equation there. We're just going to give all this information from our graph. Okay, so we're going to ignore that there's an equation. We're going to look at the graph. The graph extends from quadrant, remember they go 1, 2, 3, 4, and we read from left to right. So it extends from 2 to 4. The function has what degree, odd or even? Is it discoing? Yeah, when it discos, what degree do we have, odd or even? Odd. The leading coefficient, is it positive or negative? Negative, because it's down on the right. There are how many x-intercepts? There are actually 2, but one of them has a multiplicity of what? 2. It has an even multiplicity. The domain for every polynomial, unless it's a word problem, is XER, or negative infinity, positive infinity if I ask for interval notation. The range for every disco is what? Arrow up, arrow down. So it's going to be YER. Negative infinity, positive infinity. Okay? I want you to do B and C answering those questions. So, this one extends from quadrant 2 to 1. I forget what the next question is. What was the next question? It's a degree what? It's a degree, sorry? Even. What specific degree could this be? 4. We only have 2 or 4, right? Because we have to stop at 5. Okay. What's the next thing? I forget. It says on the page which one. Leading coefficient is positive. Okay, what's the next one? So we have 2. Domain is going to be XER. If it's a polynomial, it's not a word problem. Or negative infinity, positive infinity. My range is going to be Y such that Y is greater than, because the whole graph is greater than or equal to my Y. Please don't pick the X's. Negative 5. That was it, right? Domain and range is the last one. Yeah? Okay. This one is quadrant 3 to 1. degree is odd, and I'm guessing degree 5. My leading coefficient is positive. My x-intercepts, there are 1, 2, 3, 4, 5. So this is at least a degree 5 function, right? Because I have to have at least the number of x-intercepts to the degree, as you can max out. And then my domain is XER. What the heck is that? What back? X such that x is an element of the reals, or negative infinity, positive infinity. And because it's discoing, it's YER. Okay, we're not going to worry about this. You're going to put your masks on. I'm going to grab you the new notes. So, we've talked about a lot of this. So most of it's going to be repeat. It's kind of a repeat lesson. But the main part of this lesson is to come up with the equation of the graph. We've been given the graph, or we've been given the equation, have to come up with the graph, but we've never been given the graph and have to come up with the equation. So that's kind of where this one hits. Multiplicity of 0, the number of times a 0 of a polynomial function occurs. Multiplicity of a 0 or a root can be also referred to as the order of the 0 or root. So these ones would all have multiplicity 1 because they go straight through. So whenever a line just goes straight through, no bouncing, no curving, no nothing, 1 x-intercept there, multiplicity 1, you don't have to write multiplicity 1s. This one would be a multiplicity 1 because it went straight through, right? This one bounces. So at minimum, it has a multiplicity of 2, but it could have 4, 6, 8, 10, etc. Remembering this is called a point of tangency. So the lowest multiplicity you could have is 2. That's the lowest it could have. Okay, then we have this one that curves through it. Make sure you're paying attention. So this one does a curve through it. This S curve, right here. Okay? This is a multiplicity of 3 at minimum, or 5, 7, 9, 11. The more that would be there, it would just cause the S to like go longer along the x-axis. So the more x-intercepts there are there, it does a flatter S through it. Tangencies, the more x-intercepts there are, it does like a flatter bottom on the tangency. That's all that ends up happening. It just gets flatter because it bounces more along the x-axis. This is called a point of inflection. So I'm going to get you guys to example 1. You should be able to do it. Like I said, a lot of this is doubled up. This is the only one you're not going to do right now. So you're going to do bullets 1, 2, and 3. So this one, the least possible degree is degree what? Yeah, 3. We have 1 here and 2 here. We have 1 here, but technically a multiplicity of 2, right? So the least degree is degree 3. Now I'm going to go to this one. What's the least degree of B? 1. And how many at the least can be when it does a point of inflection through it? Multiplicity of 3, right? 1 plus 3 is 4. We know it has to be an even degree because it's in the same direction, right? So the least possible degree is degree 4. The sign of the leading coefficient. I look to my right arm. It's down. I have a negative leading coefficient. Remember, I can do LC on my notes. I can't do LC on my test. Okay? This one has a positive leading coefficient. The x-intercepts and the factors of the function with least possible degree. So my x-intercepts, zeros, roots, all mean the same thing. My x-intercepts are going to be x equals -4 multiplicity 1, which I don't need to write. It's the only multiplicity I don't have to write. And then comma 1 multiplicity 2. So that means I have x equals -4 and x equals 1. Right? When I work that one back, its factor is x plus 4, and this one is x minus 1. This one, my x-intercepts are x equals -4 multiplicity 1, which I don't need to write, and 3 multiplicity 3. My factors are x plus 4 and x minus 3. The only problem with both of these is my factors don't show the multiplicity. How could I show the multiplicity on my factors? Anyone know? Yeah. So you have to write the actual exponent as a 2 or a 3 or whatever on it to show that there's 2 of them or 3 of them there. So this one here would be squared. This one here would be to the 3. Right? And we're not going to worry about the integrals. It's just in the textbook, but not in the curriculum. How do we sketch a graph of a polynomial? Well, you could technically end up typing these ones in your calculator and matching them. We agree? Would I expect you to do anything else if they gave you an equation? No, I would expect you to do that. So we're going to skip these ones because they literally are, you could type them in your calculator and give an answer, right? So do you think they're going to give you something generic like that on a diploma where you can literally pull it out of your calculator? No. So I'm going to show you in a second, once we learn how to do the equations, what they will ask you to do. Okay? So I just wanted to show you what the textbook asks. Well, that's a generic go to your calculator type of day. I don't like that. So, this one, given the function y equals x cubed, list the parameters of the transformed polynomial function and describe how each parameter transforms the graph. So we just have to say stretches, reflections, translations. That's all I care about. I don't need the parameters as much. If you wanted to state the parameters, this would be A, this would be B, this would be C, right? So my A, this would be D. My A would equal a half. My B would equal 3. My C would equal 4. My D would equal -5. My B is actually -4, sorry. Because remember, it's minus a minus. That got it there? And C is what's back here. So this would be minus a minus. Now, even though your B comes out as a 3, it's actually a third when we state it, though, right? That doesn't change. So stretches. We have a vertical stretch. By a factor of 1/2. Doesn't change. About the x-axis. We have a horizontal stretch by a factor of 1/3. It always flips about the y-axis. Now I could go right ahead and state my transformations because this is in y equals, right? And I had a 1 in front of my x. So that's what my two things need to be. I need to have a y equals and I need to have a 1 in front. So I can start stating my stuff. Neither of these are negative, so I have no reflections. My translations, I have a vertical translation. Five down. And a horizontal translation. 4 left. The domain and range is a cubic function. Doesn't matter where it moved, how it moved up, how much it stretched, how much it didn't stretch, did it reflect? What's a cubic function's domain? XER, what's its range? YER, his disco arms. No amount of stretching, reflecting, flipping, moving up, down, left affects either a XER or a YER, right? So none of these transformations did anything to my domain and range. My domain is XER. And my range is YER. So all we have left to go over tomorrow is to culminate. I gave you a graph. How do we come up with the equation, right? Or I give you information about a graph. You have to come up with what the graph looks like we were doing earlier. And then you have to come up with the equation of the graph. So I just give you information. I say it's a degree 4. It has 3x intercepts. It has a positive y intercept. It has a positive leading coefficient. And you have to sketch something and then come up with an equation for it. That's like bringing it all together. Can you do that? That's a grand, great written response, possibly on my unit test. I don't know. Possibly. Worst drawn graphs I've ever seen in my entire life. So this is going to be the year where that's not going to happen. We're going to have pretty graphs. Because once we find our equation, what do? We put it into our graph calculator, and then we just re-sketch that bad boy. Because yours is probably really ugly. I'm not going to lie. And then you get your equation, and you just sketch it out. And now it's not really ugly anymore. Right? Everyone forgets to plug it back in and check. So, that's thinking. So your homework is going to be short. I'll tell you what it is. Page 148. Number 3, C, 4. For number 4, I want you to do 1 and 3. 2 says the intervals of like negative and positive, which we don't have to do. So 2 and 3, I want you to do C and D. Number 7. Once again, do 1 to 4, like we did in our notes. Not number 5, because that's the intervals where it's positive or negative. I don't want those. And I want you to do A to D. Now these should be quick, because none of these should ever be typed into your calculator, right? You shouldn't need your calculator. The only way you would need your calculator is for this one, when it asks you to find the zeros. So you're going to have to use your calculator to actually calculate what they are. That's it. Okay? So it should not be long. So if you have time tonight, I'm going to post right now, I'm going to post in your classroom the answers to that transformations hand-in. So if you have time tonight, go through and see how you did on it. So that by next Thursday, you can ask me questions if you didn't get stuff right. Okay? So this is short. So if you have time tonight, go through and check your transformations hand-in and see if what you got right and what you didn't. And see if you can figure out how you got it wrong. And if you can't, please circle them. And if there's coming to you 15 at lunch or before school, I don't care. I'll go through them with you. Okay?